the fundamental identity, trigonometry identity. So we're going to learn the two fundamental identities that are very important in trigonometry. So I've got a circle here, a unit circle, and I have labeled the circle 0 degree starting from right here, 0 degrees. We always start from 0 to 90 degrees, 180 degrees, that's out of the picture. This 270 degrees and back to 360. So we always go from 0 to 90, 180 and 270. When we're working on angles, we always go from 0, 90, 180 to 270, 360. We don't go in a negative direction. You have to go in a positive direction in what we call the anti-clockwise direction. So I'm going to pick up a point here, right? And that point I'm going to draw a line from the origin of the circle. Oh, okay, I've done the wrong point. So I'm using this point now, apparently. So I'm picking that point now. I don't know how my nature changes that mind so quickly. Okay, so that's the point picked. Okay, so we're drawing a line. So this generated an angle of theta. Now, obviously what happened is I've moved that from here all the way to there. So this is R, and R equals 1 in this case because it's a unit circle. And every point you pick will have its x coordinate. So let's just pull out the x coordinate and y coordinate. So this is the y coordinate. That's the y coordinate. And this is the x coordinate. So just put it here so you can see x coordinate. Right, so that's the y and x coordinate. So this is y and that's x. So that's x coordinate y. And so what we're going to do now is to derive the two fundamental identities. In order to do that, first of all, let's look at the definition of a sine of an angle here. So sine, so I'm using the word SOHCAHTOA. So ka to r. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So I'm looking at this angle here. The angle you're looking at, this is the opposite, and this is the adjacent, and that's the hypotenuse. Right, so for sine of theta, you get, well, sine theta is y over 1. So that's just y. For cos of theta, it's just going to be x. So that's x over 1, which is x. So this side here is x, a sine cos theta, and this y here is sine theta. So if I then say, well, I'm going to find the angle theta because I found my sine theta and cos theta. So let's find theta. Tan of theta. Tan theta is, well, tan is opposite over adjacent. That's opposite over adjacent. So that'll be y over x. But what is y over x? Y over x is sine theta over cos theta. X is cos theta, y is sine theta. Therefore, tan of theta, tan theta is sine of theta over cos of theta. And that's the first fundamental identity that we need to know. The first fundamental identity that we need to know. So let's call that identity number 1. Right. Now, what we can do is also use the Pythagoras theorem here. So look at that one. So that's x squared plus y squared equals 1. So using Pythagoras, so that's from Pythagoras, and we get, so from Pythagoras we get x squared plus y squared equals 1, or equals r squared, and r squared equals 1, because that's 1. I'm using unit circle here. So with a unit circle, we just made r1. Therefore, r squared is 1. So which implies that x, what is x? Cos theta. So that'd be cos theta squared plus sine theta squared equals 1. But cos theta squared is also written as cos squared theta. So the same thing. In fact, this is how it's preferred to be written, not that way, this way. So that's cos squared theta. Cos squared theta just means cos theta squared plus sine squared theta equals 1. And that is the second fundamental identity. Identity number 2. So those are the 2 fundamental identities that we need to know. That's coming from Pythagoras. Okay, another way of deriving this is basically the same thing, but this time I've got this angle A here. So let's call that theta. That's the side A. If that's the side A, in trigonometry, we label that as little a. And if this is side B, that would be little b, the opposite of it. And that's the opposite of that. And this is the right angle, and let's call that C. So that would be little c. From Pythagoras' theorem, we can honestly say that a squared plus b squared equals c squared. And if I divide both sides by c squared, so I can get 1 here, so I'll get a over c all squared, because a squared over c squared is a over c squared, plus b over c all squared. Again, if I divide that by c squared, it will be b over c all squared, equals c squared over c squared is 1. Let's just write it, c squared over c squared. So that's 1 really. So now what do we have? I've divided both sides by c squared. Now, what I now need to find is what is a over c and b over c. We're looking at that angle here. If I look for sine theta, that would be sine is opposite over hypotenuse. This is hypotenuse. This is opposite of the angle. And so it's going to be a over c. And if I look at cos theta, and that would be, well, cos is adjacent over hypotenuse. Adjacent of that angle is adjacent over hypotenuse. So that would be b over c. So if I place those, a over c all squared plus b over c all squared equals 1. So that will become sine squared theta plus cos squared theta equals 1. So that's the first or second fundamental identity, right? That's what we got on the left side here. So that's the same thing there. So we said that was number 2. So we can get number 1. So only we need to do is find the angle here. Same thing. The angle here is tan theta is, what's tan theta? Opposite over adjacent. Opposite, which is a over b. Good. A over B is tan theta. So what is A over B? There are many ways of doing this, but I could rearrange. I could multiply that by everything by C to get A, make A the subject. So you get C of C sine theta. So that'll be C sine theta over, if I times that by C to cancel that C, so I can make B the subject, I'll get C cos theta. C cancels C, and I get sine theta over cos theta. So that's what tan theta is. So tan theta, which is the gradient of this line really, that's what it's saying, because it's that height over that length over that height. That's the gradient of this line. So tan theta, if you know about gradient, it's actually equal to m, because that's what that is when you're finding the gradient of a line. It's actually the tangent of that line. And that equals sine theta over cos theta. So that is the second. So tan theta equals sine theta over cos theta, which is the first equation here. So also it's called the gradient m in linear equation.